Hey, welcome back to your favorite intermediate algebra class. We're going to multiply a couple of matrices together today. So let's talk about first of all the product being of two matrices is defined. Now this is different than scalar multiplication. Okay, here we're multiplying two matrices. We're not just taking a constant, a scalar in front of the matrix and sort of distributing it through, if you will. Okay. But for two matrices to be defined, the number of columns in the first matrix and the number of rows in the second matrix must be the same. So if you look at these two, if you're multiplying matrix A times matrix B, so you have a 3 by 4 matrix, you have a 2 by 4 matrix. Here's your rows, there's your columns, right? This is your, and then rows and columns, okay? The columns in the first must be equivalent to the rows of the second matrix. Otherwise, you cannot multiply them. Okay, so this is just plain out undefined here. Now let's look over here. You have a 3 by 4 and a 4 by 3. And you say, okay, those inside numbers are the same. In other words, the columns of the first and the rows of the second are the same. If they are the same, then the new dimensions will be those outside numbers. So this is going to end up being a 3 by 3 matrix in the end. That's the new dimensions once you've multiplied the two matrices together. So let's look at an example here and you'll see that. First of all, can you multiply matrix A times matrix B? We say, well, what's the dimensions of the first? Looks like 3 rows by 2 columns, so 3 by 2 right there. 3 by 2, and the next one, looks like we have a 2 by 2. 2 by 2. So I say, well, are the columns of the first and the rows of the second, are they the same number? Yes, they are. If so, the new dimensions will be 3 by 2. So we'll end up, make a note here, being a 3 by 2 matrix at the end. So yes, it is defined, end up being a 3 by 2 matrix. Now, let's go about multiplying these two. Let me write down matrix A and matrix B here. Alright, so what you do is you take the first row and you multiply it by the first column, and that's the position that it goes into. Okay? Well, so you take the first term in the first row, 2, times the 3, more specifically, 2 times 3, and then you add it to the 1 times the negative 1. Okay, and that's our first entry of the first row in the first column. Okay, now we go first row, second column. So now I go 2 times negative 2 plus 1 times 5. Okay, so that was the first row times the second column, and it ends up being where? On the first row and the second column that entry does. Okay, now we're going to go second row, first column. Okay, so negative 3 times 3 plus, don't forget the plus, 4 times negative 1. Okay, now we're going to go second row, second column. Negative 3 times 2 plus 4 times 5. And finally, we're getting to the last row here. 5, so row 3 times row 1. 5 times 3 plus negative 2 times negative 1. And then third row, second column. 5 times negative 2 plus negative 2 times 5. Okay, and then we just simplify this thing. So let's start up here. 6 plus a negative 1, 5. Right here, negative 4 plus 5, 1. Right here, negative 9 plus negative 4, negative 13. Right here, negative 6 plus 20, 14. 15 plus 2, 17. And finally, negative 10 plus negative 10, negative 20. Okay, so 5, 1, negative 13, 14, 17, negative 20. Okay, so it looks like we got, oh, you know what? I just saw an error I had. Guys, sorry about that. Right? Let me do it in black. This one right here with that one right there. Negative 3 times the negative 2 right there. Sorry about that. That's a positive 6 plus 20. That makes that 14. That makes that a 26. Sorry about that. Okay. Let's try another one here. Find the product if it's defined. So first of all, it looks like this first one we got 1 row by 3 columns. So 1 by 3. And the second one, it looks like we have 3 rows by 1 column. So we say, well, is that thing defined, first of all? Say, well, are the columns of the first and the rows of the second, are they the same number? I say, yes, they are. They're both 3s. Perfect. So this thing is defined, and it'll be the dimensions, the rows of the first by the columns of the second. So this will be a 1 by 1 matrix at the end. Okay, it'll be a 1 by 1 matrix at the end. So that's what we're expecting. So let's do this one real quick. As well, we take the first row and the first column. So we got that negative 1/6 times 12 plus, let's go to the next one, 1/2 times the 0 plus negative 1/3 times negative 12. So it looks like we got negative 2 plus 0 plus 4. Negative 2 plus 4 is 2. Look at that. It's a 1 by 1 matrix. Okay. Do some more. Let's do some 2 by 2 matrices here. Now here it's asking us to do AB and then compare that to BA. Okay. So let's do AB first. Here's A. Multiply matrix A by matrix B. Okay, first row, first column. So I got the negative 2 times the 2 plus, don't forget that plus, 4 times 4. Now, first row, second column. Negative 2 times 1. That's where it goes. It goes on the first row, second column. Negative 2 times 1 plus 4 times negative 3. Now we're going to go second row, first column. 0 times 2 plus 3 times 4. And now we're going to go second row, second column, and that's where we place it. 0 times 1 plus 3 times that negative 3. So it looks like we have here negative 4 plus 16, so we got 12. And then we got over here negative 2 plus a negative 12, negative 14. And then we got 0 times 2, 0 plus 12, 12. And then here 0 plus negative 9, negative 9. Okay? All right, so that's AB. This is matrix A times matrix B. That's what it gave us. 12, negative 14, 12, negative 9. 12, negative 14, 12, negative 9. So let me make a note of that. AB 12, negative 14, 12, negative 9. Okay. Now, what about BA? What would that give us? So let's do it the other way. So BA would be, so switch their order here. All right, so that would give us 2 times negative 2, negative 4, plus 1 times 0. Let's go first row, second column. 2 times 4, 8, plus 1 times 3, which is 3. Let's go second row, first column. 4 times negative 2, negative 8, plus negative 3 times 0. And now let's go second row, second column. 4 times 4, 16, plus negative 3 times positive 3, negative 9. So this cleans up to be negative 4, 11, negative 8, and 7. Now, this is BA. So this is asking us to compare matrix A times matrix B, which is up here, that 12, negative 14, 12, negative 9. Is that the same thing as BA? So it's asking us, does the commutative property of multiplication hold in matrices? Well, we just proved that it does not with one example. Okay, so a faulty example. So this property does not hold in matrices. Okay, AB does not necessarily mean it is equal to BA in matrices. Now let's use a few matrix operations that do hold. Okay, so here's the first one, A plus B times C. So let's go A plus B, and that's times the C. Okay, so let's add the first, add the first two initially, so inside the parentheses, so 3 plus the 2, so we got 5. Now we got 1 plus the 1, so we got 2. And then we got negative 2 plus 0, so negative 2. And then we got negative 1 plus negative 3, so negative 4. There's A plus B. Now we got to multiply by the C. Okay, so first row, first column, 5 times 4, 20, plus 2 times negative 3. First row, second column, 5 times 2, 10, plus 2 times 2, 4. Second row, first column, negative 2 times 4, negative 8, plus negative 4 times negative 3, 12. And finally, second row, second column, negative 2 times 2, negative 4, plus negative 4 times 2, negative 8. Okay, so this looks like it ends up cleaning up to be 14, 14, 4, negative 12. Okay, 14, 14, 4, negative 12. Let me make a note of that. 14, 14, 4, negative 12. And we'll do that next one. All right, now AC plus BC. Okay, so A times C plus B, matrix B, times C. All right, so this one Here we go. 12 plus negative 3, we got 9. 6 plus 2, we got 8. Negative 2 times 4, negative 8, plus negative 1 times negative 3, so negative 8 plus 3, negative 5. Negative 2 times 2, negative 4, plus negative 1 times 2, negative 2, so negative 4 plus a negative 2, negative 6. And then there's a big plus here. Now we go on to the next one. So 8 plus a negative 3, 5. And we're going to go there. 2 times 2, 4 plus 2, 6. First row, second column. 0 times 4, 0 plus negative 3 times the negative 3, which is 9. So 0 plus 9, 9. Finally, 0 times 2, 0. Negative plus 0 plus negative 3 times 2, negative 6. Okay. Now we add these things up. 9 plus 5, 14. 8 plus 6, 14. Negative 5 plus 9, 4. And finally, negative 6 plus a negative 6, negative 12. So 14, 14, 4, negative 12. If you look up here, you're like, oh, that's the same thing. 14, 14, 4, negative 12. It looks like A plus B times C is the exact same thing as AC plus BC. Okay, so that's your distributive property, but notice when you distributed that, you have to write the A times the C, not CA, and then the B times the C. See that there? Okay, the order matters because of that commutative property of multiplication that we said does not hold. Okay, so you have to be careful on that order. So we're listed here that both the left distributive property and the right distributive property. So make sure when you're distributing those matrices that it's in the right order there. Okay, so AB and then AC, and over here it's AC plus BC. All right. Okay, so those are your properties of matrix multiplication here. You're welcome to write those down. Little c, lowercase c down here at the bottom, that's just a scalar. Okay, that's a scalar from last section we talked about. All right, make sure you guys bring your questions to class. See you then.